Hello everyone. Welcome to one more session of live session. Today our topic of discussion is solid state drives versus HDD. Again, I welcome Mr. Ashwini Kumar Sinha and Suresh Trivedi ji for this discussion. My first question is, what are the key differences in the internal architecture of SSD and HSD?
Yeah, so one of the main key difference in SSD and the HDD, that is the hard disk drive, is the SSD do not use any kind of moving part. So if any damage or any faulty points caused due to the mechanical wear and tear uh, happen in the HDD is not present in the SSD. And HDD use the mechanical disk that rotate and over which the data is written and read using those the disk that is rotating inside of the HDD. While in SSD, the transistor are used to retain the data inside that. So they don't have any kind of moving part. They use the NAND flash memory in SSD. And so this is the main difference. One is the mechanical work. One do not have any kind of mechanical work. That's why we call it solid state. So there is no moving parts in the solid state that is SSD drive. While in HDD there is a moving part. And so that is the main big difference in that. And one holds the whole memory in the form of electrical transistor and other on the plate, moving plate.
Okay. So, how does NAND flash memory in SSDs work compared to the spinning platter in HDD?
Actually, NAND flash memory in SSDs and the spanning platters in HDDs stores data using entirely different mechanism, leading to a significant differences in the speed, durability, and the efficiency. Normally, HDDs use a mechanical system consisting of spinning magnetic patterns and the read or write head. So data is stored magnetically on the platters and the head moves to a specific location to read or write the information. This mechanical movement introduces a latency due to seek time and the rotational delay, making HDDs slower and more prone to physical wear over time. Additionally, HDDs consume more power and generate more heat and noise due to their moving components. While in case of SSDs, on the other hand, rely on NAND flash memory, which is a solid state storage technology with no moving part. So NAND flash consists of floating gate transistors that store data as a electrical charges. Unlike HDDs, SSDs can access data almost instantly, providing significantly faster read and write speeds, lower latency, and the better energy efficiency. So, data in NAND flash is organized into the pages and blocks, while reading and writing to page is fast. Erasing requires entire blocks to be cleaned fast, leading to a write amplification. To manage this SSDs imply wear leveling, garbage collection, and trim commands to optimize performance and the extend to the drive's lifespan. That's all.
Okay, so can you explain the role of the controller in SSD and how it affects the performance?
Yeah, that's a good question. The controller is the brain of SSDs. managing all data related operations and playing a critical role in the driver's performance, efficiency, and the lifespan. It functions as an intermediary between NAND flash memory and the computer, optimizing how data is read, written, and erased. One of the key responsibilities is handling data placement. Unlike HDDs, SSDs cannot overwrite data directly and must erase entire block before rewriting. The controller efficiency manages this process using a wear leveling, which distributes write operation evenly across the NAND cells to prevent premature wear. Another vital function is error corrections. NAND flash memory is prone to data corruption over time. The controller implies error correction code, normally known as ECC algorithm, to detect and fix errors, ensuring data integrity and reliability. So, to enhance speed, the controller uses garbage collection to clear unused memory block and trim commands to prevent performance degradation over time. Additionally, it manages the SSD's cache, often utilizing DRAM or SLC cache to accelerate frequency assessed data. So the difference efficiency of the SSD largely depends on the controller's processing power and firmware optimization. A high quality controller improves read-write speeds, reduces latency, and extends the drive's lifespan. Conversely, a poorly optimized controller can bottleneck performance, leading to slowdown or life inefficiencies. So, unlike the controller, is a crucial in determining an SSD overall speed, durability, and the responsibilities, making it a key factor in SSD performance.
Okay, so what are the design considerations for reducing wear leveling in SSDs?
Yeah, so current in SSD, wearing and tearing isn't the main goal in SSD design. It's actually in HDD design because they have the magnetic plates to store the data and they have the moving mechanical parts in there. So by dropping them or this kind of shock shock and vibration can damage them. So for HDD, we have to take the design consideration to optimize the wear and tear of the device because it also need to move at very high speed. So this is the in HDD it's a main goal, but for the SDD part it's not a main goal because there is no moving parts out there. But a few design consideration that we can take in SSD for its longevity is like we can. We can add a better controller that error correction codes and in the controller designing, and then we can add the beer monitoring system like controller tracks and program erase PE cycles per block and dynamically adjusting the and leveraging the strategy around that. And so these are the few design consideration we can take. But in SSD, as far I know, the beer and tear is not that much be taken as for the consideration. It's not the our end goal in those devices because they don't have much moving part that get damaged with the much use. In HDD, it definitely it's the goal to design the device so that it can withstand with the vibration, withstand with the very high speed of rotation, and all those things because they have the moving parts.
Okay, okay. So how does the catching mechanism differ in SSDs and HDDs?
Yeah. So in SSD, the caching, the main purpose of the caching is to enhance the read and write, enhance the read and write performance and reduce the wear of the NAND flash cells. Okay, and so in SSD, the cache, there is a DRAM cache that they use, and they are the they include very small amount of volatile memory, that is the DRAM. It's around 256 MB to the 1 GB, or even the highest speed for the, so if they need higher speed buffer. And then the another is the SLC cache, that is we call also called pseudo SLC. So this is another caching system in the SSD. If we go for the HDD part, then in HDD they use they also use the DRAM depending on the kind of performance they need and the kind of speed they need. And actually while using the caching, it improves the your read and write speed. So like, suppose that if some there is some blockage in the read and write of it, then that data will be cached for a few seconds, and then it will transfer. So this is it is actually for they are used actually for the remove the latency between the data read and write speed. There should be not be much delay in that. So that we use the cache, and both of the devices generally use the memory based cache, that is the what is the DRAM memory based cache, that is the volatile memory. They store the a small amount of cache buffer for a few seconds, and or depend on the needs, and it either be 256 MB or 1 GB or greater, according to the need and the performance that we want to optimize according to our use. So these are the things.
Okay. Okay. So why do SSDs have lower latency as compared to HDDs?
Actually, SSD solid state drives have lower latency compared to SSDs hard disk drives due to their fundamental design differences. Actually, first, no moving part. Unlike HDDs, which rely on spinning a magnetic disk platters and mechanical read-write head, SSDs use NAND flash memory. This eliminates seek time and the rotational latency, making data access almost instantaneous. Another parameter is the faster data access. HDDs require time to locate data physically, while SSDs to achieve latencies in the microsecond range, whereas HDD operates in the milliseconds. And next parameter, parallelism and the high-speed controller. SSDs utilize multiple NAND flash chips that can be accessed simultaneously, further reducing response time. Advanced controller and the DRAM caches also optimize data retrieval speed. Next parameter which we have to consider is the lower command queuing delays. SSD supports technologies like NVMe, non-volatile memory express, which efficiently handle multiple data required in the parallel, reducing latency significantly compared to the traditional SATA-based HDDs. And the next is the lower power consumption and head generation. Since SSDs consume less power and generate less heat, they maintain consistent performance without thermal induced slowdown, unlike HDDs, which can slow down due to the mechanical stress over a time. So overall, SSDs provide a much lower latency experience, improving systems responsiveness, boot time, and the application performance, making them to preferred choice for the high-speed computing needs.
Okay, so how do SSDs handle random read and write operations better than HDDs?
SSDs handles random read-write operation better than HDDs due to their flash-based architecture and lack of mechanical components. No moving parts. HDDs rely on the spinning patterns and a mechanical read-write head, which takes time to move to the correct data location. In contrast, SSDs use NAND flash memory, allowing instant data access without mechanical delays. Parallel data access. SSDs utilize multiple NAND flash chip and high-speed controller that enable parallel read-write operations. This significantly improves the performance while handling multiple small files or the random access workflow. And low latency and high IOPS. SSD have much lower latency and the high input-output operation per second compared to the HDDs. This results in faster response time for the application requiring frequencies, unpredictable data access such as the databases and the operating system. And another parameter is the efficient wear labeling and the trim. SSDs use wear labeling algorithm to distribute write operation evenly across the memory cells, preventing performance degradation. The trim command helps manage unused data blocks, keeping write speeds consistent over a time. Next parameter is the no seed time or a rotational delay. In HDD, random read-write operation require repositioning the read-write head and waiting for the disk to spin to the correct sector, adding milliseconds of the delay. While SSDs can access any memory cell instantly, making random access significantly faster. Next is the advanced caching mechanism. SSDs are DRAM caches and the SLCs, single level cell caching, to accelerate small random writes, further enhancing performance in the multitasking environment. So, due to these factors, SSDs dramatically perform better than the HDDs in handling random read-write operation, making them ideal for the high performance computing, gaming, and the another application.
Okay, so what are the major failure modes of SSDs and HDDs and how can they be mitigated?
Yeah. So for SDD, the major failure modes are the NAND cell wear out. So the NAND cell that is used there, they have some certain number of cycles up to which they can run. Okay, like 10,000, 1 lakh, something like that, or 1 crore, whatever they have some kind of cycle. So after each cycle, when you write the program on the NAND cell and delete the program on NAND cell. So when you write and erase the program, they degrade with each cycle of doing that. So if you write data and then erase that data, then you write a data and again erase the data. Then on each write and erase, the cell got degraded, and it get degraded, and there is a time at which it got totally failure. It's totally lost its capacity to retain the data. So that is a NAND cell wear out, and second is the controller malfunctions. So second failure points in the SSD is the controller malfunction, that hardware controller that controls the whole things, all operations are being, are being controlled based on some kind of firmware. There's some software to do that, to erase, write, read, stop the and restart, whatever the things there. There are certain kind of firmware. So if there is a malfunction in the controller, then you find some glitches in the firmware, and you find some operational, uh, operational, what say, you find some kind of glitch in the whole operation. Okay, so if it is a NAND wear out, there are some symptoms. There are few symptoms using which you can detect it, like the data errors, capacity loss, or drive failure. So sometimes you write the data, but when you read that data again, so to support it, will store some kind of video file in that SSD, and it due to the a lot of write and erase, write and erase, write and erase, due to the a lot of lacks of such cycles, that particular memory block got degraded. And so if you again want to retrieve that file, then it might give you the error, the might that file got corrupted. So this is the symptoms of the NAND cell wear out. And if there is a controller mechanism wear out, then the drive become undetectable. Sometimes locks up when you connect to the USB. It didn't get detected because there's a glitch in the firmware. So firmware is making communication with the PC, establishing things, controlling if the everything's out. So if there is some glitch in that firmware, then the drivers might be not loading, that drivers might be not detecting. So so the symptoms of the controller malfunction are the drives, the SSD become undetectable, or sometimes it's lock up, freeze up. Okay, and then each there is then other is data retention degradation. So if there is a charge leakage in the NAND cell over a time, like if you keep that SSD for a very long time, and if they are exposed to very heat, or such condition, there side might be some charge leakage in the cell, and then that data get degraded, the data retention, the data is there, but the data not be retained for longer period of time. So it might be after 10 year or 20 year, that data might be got corrupted. So the symptoms for that, how to detect that, is like when you connect, then you find some kind of unreadable data, some bits are not readable. So this is a part for the SSD part. Okay, and now let's go for the HDD. So one of the main failure point, like I earlier said, and also the Suresh sir have also mentioned that the same thing, that these HDD have the mechanical part, they have the moving part. Okay, and that, like Suresh sir already earlier told, that it uses the magnetic plate, moving magnetic plate, and that data will be physically engraved on that plate, magnetically engraved on the plate to read, and then and mechanically erased on the plate, mechanically. So if you have such mechanical moving parts, so uh, and that disk, that plate is moving at very high speeds, 1,000 of RPM. So if such thing happen, then obviously due to the friction, it got wear out. Okay, and due to the vibration, it got wear out. And as there is a moving part not only in the disk, there is also moving part that is on the disk, that the reader part and writer part, that is attached on the disk, and that has to move like this and to and fro according to so that is done using the actuator. So that actuator, due to the vibration, or due to the uh, drop, very high drop, or very high vibration, or misuse of the drive, and or shock, due to shock and vibration, all these kind of different things, the plates, the actuators, the motor can be damaged. So in HD part, this is one of main mechanical breakdown is one of the main failure points. So in the SDD, the degradation due to the erase and write cycle, the cycle matters. Okay, in SDD cycle matter, read and write cycles matter. Okay, So every time you read and write data on the SDD, erase data and then rewrite the another data on the SDD, on every cycle, it's got degraded in the SSD. But in HDD, this apart from cycle, the mechanical breakdown is the main point. So it get imposed to the some kind of shock, vibration, and all those things. Suresh have already mentioned it earlier. And did the crash? If you crash that HDD very hardly, then the plate got breaked sometime. So and the motor malfunction. So the plate have to be rotated at very high speed, and that use the BLDC motor. So motor might malfunction, the motor might burn out. So, and there is another is a magnetic data loss. So sometimes the data is, like earlier students have told you that the the data is stored in form of magnetic field using their magnetic plate. So, so data might be corrupt due to the external interference with a very high magnetic field. So my data might be corrupt using that. So these are the two different failure modes on SDD and HDD part. On SDD part, it's the write erase cycle and the firmware cycle glitch are the failure modes. But in HDD part, it's mostly the mechanical parts, external use of the external environment, how it being used in, like if you're using it in very high vibration, very high shock, or external damage due to the collision and all those things.
Uh, okay, so what impact does power loss have on SSDs as compared to HDDs?
Yeah. So like in SDD, if when like in SDD they use the DRAM, for the buffers and reading writing performance. So in data, when there is a power loss, as it is the non-volatile flash. Okay, they are using it for the buffer, like I've already told you, or for even the storing the data, they use the NAND flash. Okay, so data is, if data is already written on that and the power is lost, then the data will persist. But if it is in between that, then it might get corrupt sometime. Okay, and then the but it is not main thing. It generally not happen. The main problem is the firmware risks. So I already have told you that they have certain kind of controller, and these controller have the firmware that makes the that creates the drive interface, the drivers that controls the read and write speed, that controls the caching files, and that controls the security layers. So all those things are done by some certain kind of controller, and controller have the firmware. So if there is a fluctuation in power, or there is a power loss sudden, then it might corrupt the controller firmware in middle. So that is one of the things. And to recover that, you have to re you have to change the chip, that controller chip, or reprogram the firmware on that controller chip if the firmware got bricked, if the firmware got sometime corrupted due to that sudden power loss, or fluctuations. And then in if you go for the HDD, HDD, they are the mechanical parts. The read and write are done on the mechanical parts. So if data is already read or written on the plate, why suppose that you are writing some kind of data on the HDD, and then suddenly the power is off on the HDD, and if the data is already written on the plate, that is magnetically stored there, then power if there is power loss, it didn't affect that thing, because it's already written and it's already being on the plate, magnetic plate. When you very reinitiate that hard drive, and power it again, then you can see it there. But if there is a repetitive incidence, and then it might degrade the plate, because it's still writing some data, and then suddenly power got off, then the it is engraving the data on that magnetic field. In between that, power is lost. So the magnetic plate might got degraded, due to long term of these kind of incidents. And if you want to recover such things, then if as it is a mechanical damage, if it is the mechanical damage, it's hard to recover that. You have to change the plate and the hard disk, if the hard disk plate got damaged due to these kind of stuffs. So these are the things for the both different things. And yeah.
Okay, what are the advantages of SSDs in battery-powered devices like laptops and embedded systems? Should I repeat the question?
Yeah, just repeat the question.
Okay, so what are the advantages of SSDs in battery-powered devices like laptops and embedded systems?
Actually, solid state drives, SSDs, actually offer several advantages in the battery powered device like laptop or embedded systems due to their efficiency, speed, durability, unlike durability, etc. And unlike traditional hard disk drives, HDDs, SSD relay in NAND flash memory, eliminating the need for the mechanical components. So there are various key advantages of the SSD in battery powered devices. For example, first, when consider about the lower power consumption. Actually, in SSD, it consumes significantly less power than the HDD because they do not require energy to spin platters or move read write heads. So this leads a long battery life, making SSD ideal for the laptop, tablets, and the embedded system. Another key advantage is the faster performance. With the near instant data access, SSD improves systems responsiveness, leading a faster boot time, quicker application launches, and the efficient multitasking. This is the especially beneficial for the portable device that require instant performance. And third key advantage is the enhanced durability. Since SSDs have no moving part, they are resistant to shocks, vibrations, and the accidental drops. This makes them highly reliable for the mobile devices and the embedded system operating in harsh environment. Next key advantage is silent operation. Unlike HDDs, which generates noise due to spinning disk and the moving heads, SSDs operate silently. This contributes to a quieter and the more energy efficient experience, which is a particularly useful in the ultra thin laptops and the fanless embedded devices. Next point, key advantage is the compact and the lightweight design. SSDs are the smaller and the lighter than the HDDs, allowing manufacturers to uh, create slimmer, more portable laptop and the space efficient embedded system without compromising on the storage capacity. Next parameter is the next key advantage is the improved heat efficiency. Since SSDs generates less heat, reducing the need for the extensive cooling solutions. So this enhances overall system efficiency and prevent overheating in compact devices. So overall, SSD provides superior performance, energy efficiency, and the reliability, making them the preferred choice for the battery power device like laptops and other.
Okay, so why do enterprise data centers prefer U.2 or M.2 SSDs over traditional HDDs?
Yeah, the these enterprises level, or even if some of the consumers prefers more these SSDs over the HDD due to the combination of various factors. One is the performance efficiency, scalability, and the reliability. So let me break down one. What is the performance superiority? So in SSD, the performance is very superb and very high speed. They can read and write data up to the speed of 8 Gbps. Okay. In SSD, the maximum speed you can attain is the 200 or 300 Mbps. And if you want to use this kind of a speed, then you have to rotate the disk at very high speed, and the wear and tear will be the one of the most headache part on that part. Okay. So this speed, and if you are doing some kind of AI work, like these enterprise level obviously do some kind of AI work, or they have to transfer the data, a lots of large amount of data, and then speed matters. And these HDD can't able to provide that speed. And for the AI workloads like the AI and ML model, if they use the HDD, then it creates a bottleneck problem. So even if the CPU is very fast, even if the CPU is very fast, it is processing very fast, the data that coming from the HDD is slow. So it's create a bottleneck, like you have seen in the bottleneck. Na this side is supposed that bottom side is the CPU, and this side is the data. So there is a huge amount of data outside, and there is a huge amount of capacity on the bottle inside. But when you try to pour the water, it it didn't go with that high speed because of that bottleneck. That's why we call it the bottleneck problem in the AI thing. So that is caused due to the in the SSD mostly, the bottleneck. Even with the CPU, GPU is very fast, no matter how much fast. If the data is coming slow, they can't do anything. It creates the overall process slow. But in SSD, the data rate is very fast. Read and write speed is around 8 Gbps. So this bottleneck problem got very minimized or almost negligible if they use the SSD. That's why one of the their key reasons for the choosing the SSD for the enterprises is the speed and removing the bottleneck in the scenario like AI use. And then second is the power efficiency. Like Suresh Savar earlier also mentioned that the SSD consume very less amount of power. It's they as they don't have any kind of moving parts, and they are totally based on the NAND press, and they're totally based on the circuits. So they can be made and optimized to work on very less amount of power, and they consuming around 5 to 15 watt under load. While SSD, it has a moving part, it has the actuator, it has to run the motor, it has to run the reader, writer, and all those things. So different part, even the motor, the BLDC motor itself consume a lot of a lots of current, a lots of electricity, a lots of power. And the actuator that need to be moved on the disk, magnetic disk itself need a lot of power. So these two things, these two moving things itself needing a lot of power. That so due to this reason, the power consumption is very high in HDD, while SSD is very power efficient. So for the data centers and for the better power efficiency, the SSD performs better than SSD. So they choose this is another reason for choosing the SSD in the enterprise level. Second is the physical space and the scalability. So the physical space, so SSD can be at they are the circuits, so they can be physically make a smaller, or even soldered on the motherboard itself, like in the MacBook or in some certain kind of uh, 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 NAS system, the network storage system. You see the SSDs, the many SSDs, they give you the PCI slot to insert the SSD, or is somewhere to very optimized to make it very small, kind of very large memory, very large capacity, but still a small. They sometimes solder in the stacks, in the various stacks layer. They solder the SSD directly on the motherboard. Even in the Mac, there are few MacBooks use the to save the space and make it more a space constraint and make it more small. They sometimes solder the SSD directly on the motherboard. The SSD chips on directly on the motherboard. So in SSD, the size can be made small, can be optimized, can be soldered. But in HDD, they have the moving parts, and they have to be in separate part from the main motherboard. They have to be in separate package, because you can't solder the. It is not good idea to have soldered the moving parts, that is the actuator and the spinning wheels and all those things, and the rotating disc on the motherboard itself. It might damage the due to the vibration and all those things. So it's not feasible for those things. So physical space and scalability is the one of the another factor on which they prefer to use the SSD. And then another is the reliability, that SSD are more reliable. If you they are less prone to the wear and tear, like I've already earlier told, that our main goal in SSD is not to optimize its wear and tear. Our main goal its main goal for the HDD, not the SDD. Okay. So these are the regions, or these are few regions on due to which the enterprises prefer to use the SSD. And not only enterprises, many editors, many consumers levels like we also prefer to use the SSD, because they are very fast. There is a system that we need currently, one of the our best need for us, and many of us want to have, is the blink boot at blink. Okay, what the Windows say, or even the in the MacBook, when you so what the boot at blink, when you just turn on the switch of the computer, the Windows will open at once. It don't take loading a lot of time. Like in earlier PC, when you turn on the PC, it will take 15 to sometime 5 to 10 minutes to boot up, to get the whole things loaded on the PC, and then Windows screen will appear. But now in the current laptop, you have seen that when you press the power button, and the window open. It just blink of eye. Everything is ready to for your work. You don't need to wait the button. So this is all possible because of SSD, because of its very high speed. So as the SSD transferring whole data is very high speed, whole operating system got loaded at the blink of eye. While if they use the HDD, it's not possible. So even in the consumer level, we also prefer the SSD, not only the enterprises, because SSD performs better in many terms.
Okay, so why are SSDs still more expensive per gigabyte than HDDs?
Yeah. So this is another good question. As we have, yeah. So one thing you can, if you go for the economically part, then one thing is that it's a demand and supply. So SSD, that is not the real. I'm just joking out. So as it is very high demand, very high, very superior than HDD. So it's obvious to have the little bit of price, price fluctuation from the HDD over the SSD is high because of the demand and supply and superiority. But that's the not main part. That might be the one of the part, economically part, but that's not main part. The main part is the manufacturing complexity. So the SSD use the NAND flash, and they rely on the semiconductor NAND based flash memory. And producing this kind of NAND based flash memory use the uh, what we call photolithography. That is what we need, the silicon buffers, and then we use the photolithography to make the NAND flash. Okay. So these process, that photolithography and silicon buffers and manufacturing, it's kind of manufacturing the chip. It's similar to kind of manufacturing the chip or IC. So due to this reason, the manufacturing process is a little bit complex than the HDD. It is high, and they because these silicon buffers and manufacturing process, these factories need to in very controlled environment. They need to be dust free, and they need to be very controlled and very precise, and they need a lot of effort to do that. So that's why SSD relying of the SSD on the NAND flash makes it a little bit costlier than the HDD. While in the HDD we just need the aluminum or glass platter or magnetic material to and motor and the actuator. It's just that thing to make a HDD. So it is more simpler than that than SSD, so that it is more cost efficient than SSD. But still, but still, if you see the price over the performance, SDD I think better. This is my personal opinion. I don't know. My Some of you might not be agree with me, and if you're not agree with me, then you can comment out why you are not agree with me. Okay, so I will try to read your comment and try to get your point of view as well. But in my point of view, even though it is costly, if you compare with the performance, it's a decent. Okay, it's not that much costly.
Okay, so how do advancements in NAND technology affect SSD pricing and performance? Should I repeat the question? Suresh sir, you are on mute.
Just repeat the question.
Okay, so how do advancements in NAND technology affect SSD pricing and performance?
Okay. The advancement in the NAND technology, such as SLC, single level cell, MLC, multi-level cells, and TLC, triple level cells, and the QLC, quad level cells, directly impact the SSD pricing and the performance by influencing speed, endurance, and the cost of the cost per gigabyte. So when we are talking about the performance, the NAND type differ in the number of bits stored per cell. For example, when we are considering the SLC, means 1 bit per cell, fastest with the lowest latency and the highest endurance, used in enterprise and the high-end application. Another is MLC, 2 bit per cell. It is balance, speed, and the durability used in the premium consumer and the professional SSDs. TLC, 3 bit per cell, common in consumer SSDs, offering a balance between cost and the performance. And QLC, 4 bit per cell, higher density but slower speed and the lower endurance due to the increased program per erase PLE cycle per cell. And the next is the endurance. NAND endurance decreases as more bits are stored per cell. SLC has the longest lifespan, followed by MLC, TLC, and the QLC. To mitigate this, SSD uses wear labeling and the caching technique like SLC caching in TLC and the QLC drive to improve the performance. Now come on the pricing. High density NAND, TLC and QLC reduced manufacturing cost per gigabyte, making SSDs more affordable. QLC drive offer the lowest cost per GB, enabling large capacity consumer SSDs. However, they trade off performance and the durability compared to SLC and RMLC. Now, use cases में an SLC RMLC, it has a high performance, write intensive workloads, database, enterprise, and the storage. And TLC, general consumer use, gaming, and the mainstream computing. QLC, budget friendly storage, arrival purpose, and the light workloads. So when we summarize all the things, while QLC lower SSDs cost, SLC and MLC remains superior in speed and the durability. The right choice depends in the balancing price, endurance, and the performance needs.
Okay. So my last question for the session: what are the emerging storage technologies that could replace SSDs and HDDs in future?
Yeah, I think it's one of the best question that I have to end the session with. Yeah, because it's really interesting question. Yeah. So till the evolution of this memory and this storage system, before we go, we have some one of the best and the finest and one of the most efficient way of storage system. Sorry for that. Yeah, the storage system that is already there around us and we already have. Uh, that is the DNA. Okay. So DNA is coded in four variables that are A, C, T, and G. So these are four variables we can store in the DNA, and each DNA, it's very small. You can see very small. It's very macroscopic. You can't see it with the eye. Each DNA, each DNA and 1 gram of DNA can store 1 exabyte. And it means 1 million TB uh, uh, of the data, 1 million TB of the data, 1 gram of the DNA can store it. Okay. So is till now, whatever the things we have discovered till now, whatever things we have made, it is on the finest storage system till now we have. Okay. No other kind of technology can beat this. This is one of finest storage system in the entire world. That is the DNA. It can store 1 gram of DNA can store 1 exabyte of uh, data. That is 1 million terabyte of data in the 1 gram and very power efficient. So what scientists trying to do? Trying to store the data in the form of DNA, ACTG, two variables. So currently in what SSD or HDD, we store the data in two formats only in a bit like 0 1. There are only two variables. It's either v0 or v1. But in DNA we have the four variables. So not only the extra variables that gives you the better you know better choice, but also the storage and the whole thing. So currently, many scientists, many researchers are developing the storage system that is called DNA-based storage system, so that they can uh, encode the 0 and 1, that is bit data, in the pair of ACTG, the variable, so that 0 1 trans can be translated into the DNA codes ACTG variables. That is the DNA's way of storing the data, four variables. So these two variables been encoded into the four variables, and then that data been stored in the DNA. So if we got succeed in this, then we have the 1 exabyte of data storage system in just 1 gram of DNA. That's the excellent job that we are going that many of us are trying to do. And let's see the future of this, how much we got succeed. But till now, whatever the storage system we have discovered or been discovered in few more years, it is one of the finest storage system till now. So this is the one thing. And then second development is the resistive RAM, that is ReRAM, what we call. Okay. So ReRAMs are the material that change the resistance when the voltage is applied. Okay. There are certain materials that changes, like you have seen the glasses. There are a few glasses out there in the China, Japan. When they press the switch, when they power it, the glass got translucent or something like, because it's changing the shape is changing because of the current. So there are few materials. So it is a material science of things. So few scientists are developing. So finding out these material that change the, just in very small amount of power, they can change the shape when or they can change the resistance when based on the voltage. So if we able to find such material, then we can use that material to manipulate the resistance based on the voltage and store that resistance. We can store the data in form of the resistance. Like if there is high resistance, then it's the 0. sorry, then is the 1 bit. If the low distance, then it's the 0 bit. That 0 1, we can store the 0 1 in form of the resistance. So that is the ReRAM things that we can store the things in, if we use this thing, then it is 1,000, not one, not 10, not the 100. It's the 1,000 times faster than the SSD. So this is the another interesting feature of the storage system, that is the ReRAM. If we succeeded, then we can get more faster SSD, and we can for the AI workloads, it is the one of the best thing. We can eliminate more efficiently that bottleneck problem that I have told you earlier. So the another thing, and then the another next thing is the page change memory, that what we call the PCM. So this is another, and then is the magnetic RAM, MRAM. So these are the so if you see all those things, and there is another one, the quantum storage. So now we are going for the quantum computing or quantum storage. So we are trying to make a quantum superposition, and we are doing the trying to store the data, making a storage system based on the quantum dots or quantum storage. So this is another. So if you ask me, most interesting research that has been going on, and that might, if got successful, that might be change the game in the whole history of the storage system, that is a DNA based storage system. So if we able to succeed in storing the data, the bits of 0 1 in the variables of ACTG, that is the DNA codes, the DNA variables, then it's one of the finest discovery that we can done. Okay. So this is the answer. I think if Suresh sir also want to add, then you can add also, if you have any more such interesting things in your mind, or if you want to say some kind of final words to the viewer.
No, I don't want to explain anything.
Yeah.
It's sufficient. You have explained very clearly.
Okay. Yeah. So yeah. So that's it.
Okay. Okay. So I think this brings us to the end of the session. If you have any questions, you can post in the comment section. Thank you for your time, Ashwini ji and Suresh ji.
Thank you. Thank you very much.